Okay, this class we're gonna learn the real applications of a normal distribution. If we are talking about a normal distribution, so it means just the general case of the normal distribution. So first we know what is the standard normal distribution, right? Standard normal distribution should have these two conditions. Mu is equal to 0, mean is 0, and sigma, standard deviation, is to 1. So here we were working on the normal distribution, not standard, which means the mean is not 0 or the standard deviation is not 1. Standard deviation is not 1. So if we know the normal distribution is not a standard one, we need to standardize it first. Because after we standardize the general one to the standard one, then we can use the z-table. Remember, the z-table is just about the standard normal distribution. So that's why we need to standardize. So the formula is not shown correctly, so I will rewrite the formula. X minus mu divided by the sigma. So I think in your point, the formula is correct. And always round your z-score to 2 decimal places. 2 decimal places for any z-score, because in your z-table, the z-score has 2 decimal places. Again, for the first value is our x value. So this one means transfer our x to the standardized score, z-score. The first value is always your x value, the value you are testing, okay? And this one you will realize is just the formula we previously mentioned in chapter 3, Z transform formula. So convert the x value to z-score. They are just the same formula. So why we could convert a non-standard one to the standard one? Because from these two shapes, we realize they're just the same shape, right? And the area of the shaded part will not change. So we can convert the non-standard one to the standard one. Then we can use the z-table to find the area. Because if we use the z-table to find the area, it's much easier to get the probability. So this is the procedure, how to find the area. This time, it's about the non-standard one. So it's very similar as finding the area with the standard normal distribution. We only need to add one more step. Because last class we talked about how to find the probability with a standard normal distribution. This time we're talking about the non-standard one. So we just add one more step. We need to convert the non-standard one to the standard one. This is called the standardize, right? So let's check the first step. First step, we need to sketch a normal curve. So for example, we have a question. First step, we need to sketch a normal curve. We draw a bell-shaped curve, and we know for any bell-shaped curve, for any normal distribution, the mu, the mean value, is always in the middle, right? In the mid, we can put mu is equal to some number here. Then we label the specific x value. For example, if our x value is greater than our mu, then we know the x should be on the right side of the mu, right? If the x is smaller than the mean, the mu, then we know the x will be on the left side of the mu. So for example, here we have mu is equal to 4, and I have x is equal to 2. So here x is smaller than mu, so obviously x is on the left side of the mu. So this is how to sketch a curve. First, draw a bell-shaped curve, then label the mu in the middle, then label the x value. Make sure you know it should be on the left to the mu or to the right of the mu. Then we can shade it the part. So for example, we know this is x, right? So we'll put a bar here, and if we are interested in the probability greater than x, so we will shade it the area to the right. If we're interested in the probability less than x, or less than 2, I will say here, less than 2, then we will shade it the left part. So here, for example, we say we are interested in the probability x is smaller than 2, then we will shade the left part. So the first step, try to sketch a curve to help you understand. The second step, we need to convert the z, right? Convert to get the z-score. So we should use the x value to convert it to the z-score. So we will say the first step, we list the mu. Then second step, we know the c is in the middle. C is equal to 0, right? And we convert this x to the z-score. This z is the mu of this standard normal distribution. And we convert x value to the z-score. We convert the x value to the z-score. The second step just tell you we need to use this formula. Again, x value first minus the mean value divided by the standard deviation to get your z-score. So in our case, it will be 2 is our x value here. And minus the mu. Mu is 4, right? Divided, for example, I would say the standard deviation is 0.5. For example, let's set the standard deviation to be the 0.5. It's always given by the question, right? So this time we will get a 4. It should be negative 4. This just show you we should convert our x to be the z-score. Step 3, after we have the z, we use technology or the z table to find the area we shaded. So in our class, of course, we need to check the z table. Let's check this example. So the example is talking about what proportion of men. So here, proportion is another way to talk about the probability. So we can also say what probability of men are taller than 72. So make sure you know it's taller than. So it should be the area to the left or right. Let's think it over. Let's see the question. Heights of men are normally distributed. So we know it's a normal distribution. And we also know the mean. So this is our mu, right? And we also know the standard deviation. So that's our sigma. But this time we know mu is not 0 and the sigma is not 1. So this one is a non-standard normal distribution. We are interested to find the percentage of men. Percentage of men here is just the proportion of the men. It's just the probability of men. How can we get to the proportion, probability, percentage? We always check the area under the curve. And here we're talking about taller than a shower head at 72. So here we have 72, greater than 72. So this, if we translate the words into the symbols, we can say we find the probability x value is taller than 72. So if we use the symbol, we will write like this. Probability x value is greater than 72. So first step, just like I said, we need to sketch a curve. So we sketch a bell-shaped curve first, then we list the mu in the middle. Mu is always in the middle of your normal curve, right? Then we label the x value. And we realize this time the x value is greater than our mean. 72 is greater than 68.6. So it should be on the right side of the mean value. So we label it 72 about this position, right to the mean. Then we know we are interested in the probability greater than 72. If we are talking about greater than some value, it means the area to the right side. So that's why we shaded the right tail. So we are interested in the area of this right tail. So this is the first step, right? Second step, we need to convert our x value. So here, what is the x value again? It's the value we are testing. We go back to check. The value here is 72, greater than 72. So we know the 72 is our x value. 72 is the x we are interested in. We are going to test, right? So we put x equal to 72 in our formula. 72 is the x we want to test. So minus the mu divided by the standard deviation, we got 2.8. So that's how we get this z-score. After we convert the x72 to the standard score, we got the z-score 1.21. So the step 1 we sketch, step 2 we convert. So this one just show you. How can we get? We round 2 decimal places, right? Step 2, again, step 1 sketch, step 2 convert. Convert to what? Convert your x to z. That's called standardize. So step 2, get your z-score. Step 3, we need to check the table or use technology. So if we use tables, so we should be careful. We will first use the z-score to check our z-table, right? Because we have the z-score. We can check the z-table. And this one is a positive value. We check the positive z-table. The first 2 digits are 1.2. So we check the left column. Left column of your z-table to find 1.2. We find the whole row. Right? We have lots of values in this row. But which one is the value we need? We still need to check the last digit, 1. So here the value is 0.01. We check the top row for the last digit, 0.01. So we realize the second value in the row. Second value in this row is the value we need. So from your table, from your z-table, it's 1.21. You will find that the area is 0.8869. You can try to check the table with me, right? So check the first 2 digits first. 1.2. Check the left column, 1.2. So you can find that you have the whole row. Then we check the top row, 0.01, because that's the last digit. Then you can locate which one. In this case, it's just the second value in the row. We have 0.8869. So this value directly from your table. Next step, we should ask ourselves, is that the correct one we are interested in? Think it over. Remember, the C table always give you the area cumulative to the left. So this 0.8869 from your table actually is the area cumulative to the left side. So the red shaded part is 0.8869. It's obviously not the green shaded part we are interested in, but it's possible to get the green shaded part, right? We know the total area under the curve is just 1. So we can use 1 total area minus 0.8869. The area to the left, total area minus the area to the left. We will definitely get the area to the right side, because there is small difference between these two values, because this one is from technology. If you check table, you will just get this value, 0.1131. Again, if you are interested in the area to the right, you need to use the total area minus the area to the left, because table only provide the area cumulative to the left. So this step is important. Okay? So in our class, we will get this answer, 0.1131, because we do not use technology, right? So this step just show you how can we get this one. First, we convert our x to this c, then use this c to check the table, we will get this value. But it's not the final answer, because this time we are interested in the area cumulative to the right. So we need this step. So after that, we just try to interpret our answer, because we know, so here we were going to use this one. 0.1131. So we know the proportion of the probability of men taller than 72 inch is 0.1131. So we will say, because the question asks me what proportion, so what percentage, or we will say about 11% of men will find the design to be not suitable, because they are 11% of the men, even higher than 72, even higher than the showerheads. Of course, they will find uncomfortable about the design. So this is for this example.